Assalamu alaikum. In this problem, we are given an unsorted array of integers. We have to return the length of the longest consecutive elements. Okay. So, if we consider this test case, here one, 2, 3, 4, 100, 200. Now, this is a consecutive sequence. This is consecutive sequence. This is consecutive sequence. Here the length is 4, length is 1, length is 1. The longest consecutive element sequence has length 4. So the return value will be 4. Again, if we consider this portion, this test case, here we can see that we have integers from 0, 1 till 8. So the length of this consecutive sequence is 9. So the output is 9. Okay. Now how can we do this? The main problem is this complexity barrier. We need to find an algorithm that solves it in order of n time complexity. So we cannot sort the array. So one thing is that sorting is not allowed. Again, we cannot use set as set as additional log n complexity. So if we use set, then the complexity would be n log n. So we cannot use set. So we need to use unordered set. Unordered set. Okay. Now, if we consider this example again, 1, 2, 3, 4, 100, 200. We have seen before that this is a consecutive sequence, this is the consecutive sequence, this is the consecutive sequence. Okay. So this consecutive sequence is starting from 1, this starts from 100, and this starts from 200. So why it is starting from 1? Why not from 2? Because if we consider 0, 0 is not in this array. Again, 99 is not in this array. Again, 199 is not in this array. So we can easily say that this will be a starting of any sequence. Again, this will be a starting point of any sequence, and so on. Now, how can we check 0 is not in this array? We cannot traverse it. What we can do is we can use unordered set. So we'll keep these elements in unordered set. So it will need complexity of order of n. Okay, no problem here. And now what we will do is we will traverse this unordered set. When we see that, let's say when we are traversing 100, we are checking 100 if it is starting position or not. We will check if 99 is in set, is in this unordered set or not. If 99 is not in this unordered set, then we can say that it is a starting position. Again, when we are checking for 1, we will look for 0 in this unordered set. If we find 0, then 1 is not the starting position. If we do not find 0 in this unordered set, then 1 is the starting position. Okay. When we have confirmed that 1 is the starting position, then what we will do is we will check for 2 in this unordered set, again 3, again 4, and so on. Okay. When we are checking for 5, 5 is not in this unordered set. So we can say that these 4 elements are consecutive elements that are in this array. and the length is 4. Again, when we search for this from this position, we can find length 1, and from this position we can find length 1. The answer will be 4. Okay, now if we uh, try to see the coding portion, this is the solution. Okay, first of all, let's see the solution in C++. Now we are taking another set here and inserting it in another set. It will be of order of n time complexity. Now we are traversing this set and checking if the present value, let's say it is the present value z. If z minus 1 is not in set, if it is not in set, then we enter this if condition, and let's say it is z. Now as we have got this, so count will be 1. Count is 1. Okay, so we do not need to check this one again. We will start checking from this position. So it is now equals z plus 1. So again we will check for this if it is in set or not. If it is in set, we will increase now. So now will become 3, and we will increase count will become 2. In this way, when we try to find 5, then count becomes 4, and now becomes this 5. We initially set answer to 0, and then we find answer by taking the maximum value of previous answer and the current count. Okay, so finally we return the answer. Here one thing is, this may seem to be uh, of n square complexity, but it is not. Why not? Because when we are traversing this unordered set, or we are considering these numbers, what we are doing, we are only in this portion we are only traversing these consecutive elements, these consecutive elements. So for 2 we are not traversing this, or we are not traversing this. We are only traversing the whole area only for 1, only for 100, only for 200. So it is like of linear, though it seems like it is of complexity order of n square, but the full thing is of complexity order of n, or we can say that order of n plus n something. So order of n. Okay, the same approach is taken for Python. What we have done is, we have taken a set. Here this set is equivalent to the another set we have taken in C++, and the array elements are now converted in set. Now initially we are taking answer equals 0. Now we are traversing each element of this set, again using the same logic that if the previous element num minus 1 is not in set, uh, then we okay, so again consider this example. If the previous element or 0 is not in the set, then we keep the value of count equals 1. Why 1? Because we are sure that this value is in set. and we try to check from this value. Okay, again, here it is num, so we are increasing num by 1, and then we are checking if these values are in set or not. If these values are in set, we again increase num and also increase count. So finally we uh, take the maximum value of previous answer and count in answer and return answer. Okay, thank you.